Okay, derivatives. All right. I will give you the definition of the derivative. Yay. So this is limit as h approaches 0 of f of x plus h minus f of x divided by h. All right, so this is kind of like our formula. Definition of the derivative. All right. So let's say I had a question of f of x equals x squared plus 3. Okay. So to answer this question, if we're being asked to find the derivative of this function, we're going to take our definition of the derivative and we're going to use it here. Okay. So, or like we're going to like kind of smush them together. So, right, definition says f of x plus h. This means that I need to take x plus h and I need to plug that in to wherever my x is. Okay. So the function x plus h. So I need to take my function x plus h, square it because of the square right here in the function, my plus 3. Okay. Cool. And then I need to minus what? F of x, right? That would just be minus x squared plus 3. And then divide by h. Cool. So we take the skeleton of the definition of the derivative and we're applying our function. So now that we have this, we can start kind of whittling it down. I'm going to FOIL out the x plus h. So that would be x squared plus 2xh plus h squared plus 3. And then the tricky thing here is that this negative, this minus f of x that we see in the definition, that will always distribute, right? So it would be minus x squared minus 3. Okay, so don't get caught up by that. And then all over h. Now, if we look at this simplified, or it doesn't look simple, but if we look at it all multiplied out, we will immediately see that we can cross some things out, like these x squareds. Minus 3 right there. So I'm going to rewrite this. 2xh plus h squared divided by h. All right. Next step, I could pull out one of these h's from each part in the top. So h times 2x plus h divided by h. And then these would cross out like this. Okay. So we're nearing the end. Let me bring back that limit as h approaches 0. Now of 2x plus h, right? How do I do a limit? I just plug it in. That's my first step. So the limit, plug in 0 for h, you would get 2x. Ooh, cool. Okay, so it's not too bad. I know it can be a little tricky getting it set up here with like the x plus h squared. But you're only going to see 2 definition of the derivative questions on the quiz. Okay, derivatives continued. We have power rule first. Okay, so instead of doing this, what we did earlier, this definition of the derivative. Yes, this sucks. I know. Power rule is awesome. Okay, you just take, let's say your function is x to the n. The derivative of the same function would be n brought down to the front times x to the n minus 1. Okay, so let's see this guy in action. Some examples. Let's say my function was x squared. Okay, how do I do the derivative of this? You're going to bring the n down, which is in this case is the 2. So 2 times x, and then what is 2 minus 1? Just a 1. So your answer is 2x. Let's say we had x to the 4. Okay, it's the same idea. We're going to bring that n down, and then we're going to subtract 1 from our variable. Okay, what if I had, we're just going to blast through a couple of these, just an x. All right, well, technically, x just by itself is x to the 1. So if I apply the power rule here, the derivative of function equals x would be 1 times x to the 0, which is 1. So you get 1. Okay. What about if I had like a 7? Okay. The derivative of this, right? Technically, guys might hate this. Technically, an x to the 0 exists here. Okay. So if I know that, I'm going to apply the definition of the derivative. Or sorry, apply power rule. Bring the 0 in front, because this is the 0. So 7 times 0 times x to the negative 1. But the 0, so powerful, just kills everything else, giving you just a 0. So anything that doesn't have a variable, that's just a constant, just a number, the derivative of that is just nothing. It's just 0. Okay? Let's try something that's a little bit harder as we wrap up power rule. Maybe we can do 3x, negative 3x. Oh, actually, let's do a few more. So why don't we do 1 over square root x. Okay. I'm going to rewrite this 1 over x to the 1/2. And then, right, power rule, the caveat for power rule is you cannot do it with a variable on the bottom. So we need to bring this x up like this. Okay. And now I'm just going to apply power rule like we always do. Negative 1/2 times x to the, what is negative 1/2 minus 1? Right? That would give us negative 3 over 2. Okay. And then a negative exponent, we need to bring that down. So that would be negative 1 over 2 times x to the 3 over 2. Oof. All right. What about square root of x? Should I have started with that? Right here. Okay. It's the same idea we just did. But I'm going to multiply by the n. I'm going to first rewrite it and then multiply by the n. And then I need to bring this negative exponent down like this. Okay. And then that would give me 1 over 2 square root of x. Cool. Okay. We can do one last one. Let's say I had a constant in front. Right? How do I do the power rule? You just attach it to the constant. You could ignore this negative 3 actually first, if that makes life easier. Do the derivative of this guy, which is 2x, and then reattach it like this. Cool. Okay.